We've just been looking at the psychometric chart and we tried to represent on it the comfort zone by drawing in a rough circle, oval shape. I tried to represent the comfort zone. To make it clearer, we have what's called a bioclimatic chart. The bioclimatic chart clearly identifies the comfort zone. On the x-axis, we have the relative humidity. On the y-axis, we have the dry bulb temperature. The relative humidity is easy to plot. In the exercise of a few minutes ago, we had a relative humidity of 70%. The dry bulb temperature was 23 degrees. So 23 degrees plots about here. And we move across and we intersect with the 70% relative humidity. This is going to bring us to a point about here, which tells us that we're pretty close to the comfort zone, and it's a little bit out of what we would accept. This dash, dash, dash line indicates that it's borderline. The next example that we looked at was 65% relative humidity, and we looked at 25% dry bulb temperature. So the 25% plots here. We then plot across, intersecting with the 65%, and again, we're right on the border of the comfort zone. The next example we looked at was 40% relative humidity. In this case, we were looking at a dry bulb temperature of 30 degrees. Moving across, moving up, we plot again right on the border of the comfort zone. Last example we looked at was 25% relative humidity. But in this case, we had a dry bulb temperature of 35 degrees. Again, plotting across and up, we can see that we are out of the comfort zone. But this is the beauty of the bioclimatic chart. It tells us how we can achieve a comfortable condition. By introducing air movement, we can pull the temperature down to a comfortable temperature, the comfort zone. And so in the case here of 25 degrees relative humidity and 35 degrees dry bulb temperature, by introducing air movement at 1 metre per second, we can pull the temperature down to something that would simulate a comfortable zone. The trouble is here, we are again in this dash, dash, dash line, which is borderline for human comfort. The beauty of the bioclimatic chart is we can see how we can use air movement to pull the temperature down. If we have 0.1 metres per second, we can pull it down into the comfort zone. The other beauty of the bioclimatic chart is it tells us when we have temperatures down to 10 degrees Celsius through to 20 degrees Celsius, how many watts per square metre need to be introduced. So let's say if the dry bulb temperature is 15 degrees, we would need to introduce 500 watts per square metre in order to pull the temperature up to something close to the comfort zone. 800 watts per square metre would pull it up into a comfort zone. A very valuable device to use in building design.